So we come to full stack development. So all of this is very important for you as developers, because if you're not good with problem solving and if you don't come up with with that mentality of software development, then it becomes very difficult for you to be a full stack developer. Now, full stack development seems to be a very fancy word to hear, but it's not that difficult to understand what full stack is. So first you need to understand what a stack is, right? So let's say I have a let's take an example of Airbnb. Okay, I have a Airbnb type of service where all I do is I have to create a facility for my users where they can book rooms at different places in the world. So now this application has multiple parts to it. One is the back end of it, then there is front end, then there is DevOps, then there is other things related to it, but all of them they come under the umbrella of back end, front end, and DevOps. So the set of technologies that are used in order to build a software product is called a stack. That is called its stack. Now, when I say let's say I am doing a product called Airbnb, and I say I'm using, okay, Python as my backend service, React as my front end service, and then I have MongoDB as my database. I'm using microservices to deploy, and I'm using Docker. I'm using Docker to deploy it. So Docker, Python, React, Kafka, Mongo, this is my stack. The list of technologies that you use in order to build a software system is called as a stack. So now, what do you mean by full stack? Full stack is your visibility on the entire stack, as simple as that. Now, when you say MERN stack, you have Mongo, you have Express.js, you have React, and you have Node, correct? So now Mongo is your database, React is your front end, then you have either Express or Node in your backend service. So since you have the visibility of the entire stack as to what I'm using at my front end, what I'm using at my back end, and what I'm using at my DB, and how my deployment work, you are called as a full stack developer. Now, there is a common misnomer around full stack development is that as long as you are a front end and a back end developer, people start calling you a full stack developer. But according to me, that's not right, because just knowing front end, just knowing back end is not what makes you a full stack developer. According to me, a full stack developer is someone who has an end-to-end view from front end till the deployment phase. Now, what do I mean by that? What do I mean by back end? What do I mean by front end? What do I mean by DevOps? Okay, so let's say Airbnb as an example. Now, for Airbnb, what I should do is I should actually have a backend service. When I say backend, this is my service which actually manages all my data. When I say data, my user data, all the rooms that are available, all the rooms that gets registered, and then all my booking data, like which user has booked which room, which user has left which room, how many are left right now, and how will I segregate these rooms based on location, etc., etc. Anything that manages your data is called as backend. Now, in order to manage your data, you have something called as APIs, that is called as application programming interface. You can write APIs in Java, Python, React, Node, PHP. You can write APIs everywhere you want. So APIs are these interfaces for users to enter and retrieve this data. Say, for example, in an Airbnb type of system, there can be basically three type of actors, right? One actor who lists his room or a villa on Airbnb. Then there's another actor which is user who actually books these rooms. I am a user. I just go. I think, okay, COVID is all done. I am allowed to travel. I want to go to Goa, so I'll go to Airbnb and I want to book a villa. So I am a user. I'm the actor number two. And the actor number three is the Airbnb company itself, which actually aggregates these users and hosts. Now, for all these actors, if I want to enlist my room to Airbnb should provide me a facility, right? That facility is called as an API. If I want to book a room or a villa at Goa through Airbnb, then Airbnb should give me a facility. That facility is again called as API. So APIs are facilities for actors in order to enter and retrieve information from the system. This is called as backend. Now, this is what you write in your node. You might have written APIs, right? You might have written APIs where for multiple purposes. So backend is what hosts all your APIs. Backend is what manages all your data and logic and stuff like that. Then is your front end. Front end is your screen. That's all. In layman terms, front end is your screen. So let's say we have Zoom, right? So in Zoom, so there is a landing screen. Then you press to a button to join a meeting. So that's the second screen. Then we have this screen where we are discussing right now. So all of these interfaces through which a user communicates with your system is called as front end. So now this front end is written in React. It can be written in Angular. It can be written in Laravel. There are multiple technologies. Even for backend, there is a huge plethora of technologies: Java, Python, PHP, Node, the popular ones. There is Ruby on Rails. There is Groovy on Rails, and things like that. Front end, again, there are a lot of technologies. The most popular one is React. Now, why is React so popular? I'll tell you maybe in some time. So that is front end. Front end is your screen, back end is your data management. Then there is DevOps. DevOps is nothing but development operations or dev operations. Now, once you have built your application, let's say you have built your screens, you have built your APIs, but you want this to be made available for the outside world. How will you make it? You have to take this entire application, go and deploy it somewhere, right? So this is what DevOps does. DevOps actually ensures that your software is available to the set of intended users. So you have your front end, you have your back end. So what DevOps does, DevOps actually creates runnable builds of your backend, runnable builds of your front end, takes and deploys it. And whenever you want to scale it, it will scale it. Whenever you want to scale down, they'll scale it down. So DevOps is the operations surrounding your application. So someone who is good with backend, not good exactly, but someone who knows backend, who knows front end, who knows DevOps is what is called as a full stack developer, not just backend and front end. And even in backend and front end, you might know, say backend, you know Node.js, and front end, you know React.js. Are you a full stack developer? Not exactly, but yeah, you can be considered full stack developer in the current realm, because in the current world, that's the definition. But technically speaking, you should be good with all the three. You should at least know a few backend and few front end so that it can be plugged and played anytime you want. Okay. So this is what actually makes you a full stack developer. And you guys are anyway doing Node. So for you, JavaScript is an easy option where you can do front end and back end both. You do React.js, that will be your front end. You write code in Node.js, that will be your back end. Then DevOps is something that you might not have full visibility on right now. But yeah, so that's a phase which is also very important for you guys to progress in your career as software developers. Then QA is the quality assurance, the testing part of things. Most people actually look down on QA, but I am someone who has who actually pays high amount of respect and high amount of importance to QA, because without quality, your product is nothing. No matter how good of a problem solver you are, no matter how beautifully your code is written, no matter how fluid is your deployment, but if the product lacks in quality, the product is a failure. Let's say we are doing a Zoom meeting right now, and it has a beautiful UI. The API document of Zoom also tells you that they have a very beautiful backend. But if Zoom does not perform the way it should perform, the service is a failure. The product is a failure. So it's very important for you to test your features. This is a problem with most of the developers. Most developers assume that QA is not their part of the work, but technically speaking, QA is also their part of the work. When you develop a feature, when you write code for a feature and you say, okay, this is my feature, you test it, it is your responsibility that you test it very well beforehand. So quality assurance is something very important for every developer. So when you are not only coding your backend, not only coding your front end, not only making this necessary setup for your application to be deployed, wherever you want it to be, but also quality of this product is something an engineer, a full stack developer should be aware of. You might think that, okay, if backend, front end, DevOps, QA, all of it is being done by one single person, then what is the purpose of having separate developers? Of course, that might be one of the questions. But if you want to be a full stack developer, if you see your career as a full stack developer, you should have visibility of all of this. You can be a backend developer, there is nothing wrong in it. You can be only a front end developer, nothing wrong with it. Only DevOps, only QA, nothing wrong with it. There are hundreds and thousands of people who are doing it. But if your aim is to be full stack, if your aim is to be someone who has the entire visibility of the product, you should be good with all of this. So yeah, and that's how you can decide as to how will you dedicate your time for all these technologies. Okay, scalable systems. See, this is something very important for all the engineers. See, usually what happens, what we observe in a lot of engineers and what are developers is that you might have come up with a good solution. You might have written your code in a very beautiful way. You might have had a very good visibility of all the technologies involved. But if you don't know how to scale your system, then again, it's a failure. Say, for example, Zoom is working fine. Zoom is a very good product. They have a good backend. They have a good front end. They have a very good development team. They have a very good API documentation. Their deployment and everything works fine. But what if it works for just 5 of us? It should be working for millions of users that are using this system, right? So that is where scale comes into picture. Solving a problem is one. Solving a problem at scale is a altogether a different ball game. Okay, and this is what most engineers struggle with even today, because a lot of them are good problem solvers, a lot of them are good developers, but a lot of them are not good problem solvers at scale. So scaling is when you ensure that your system operates for a huge amount of users. Let's take the same Airbnb type of example. Let's say we have built an Airbnb. So I had a set of backend developers who actually built the entire data management system. There is a front end developers who actually built beautiful screens, beautiful colors and gestures and everything. Then there is a very good DevOps team who actually deployed it into a system. Now Airbnb is live. Now what happens is, let's say, oh, okay, let's take Coven for example. I mean, that's a very recent use case. So when Coven announced that it is vaccination registration is open for 18 plus, that was on, I think it was day before yesterday after 4 p.m. or something. So once that happened, you guys saw how the system crashed. Before that, the system worked very well. Before that, a lot of people have registered for their vaccination. They got their vaccination done. But after 4 o'clock on that day, it crashed. That is because Coven received around 25 lakh requests per second. Now, what does that mean? That Coven was a good solution for a problem that we have right now. But it was not a good solution at scale. It was not a solution that was built for scale, because when there were around 1,000 or 2,000 requests per second, it worked fine. But when there were 25 lakh requests per second for registration of the vaccine, it failed. This is where the problem comes. This is where scaling comes. If your system is not scalable enough, if your system is not configurable enough, then your system is bound to fail. Your product is bound to fail. So it is always important that you develop your products, you write your code, you deploy your system in such a way that it is configurable, it is scalable at any given point of time. Which is exactly why we can speak of evolution of the software architecture. So basically, the entire software architecture has been swinging between two standard architectures. One is monolith, and another one is microservice. Everything else you see falls under monolith, like monoliths or micro monoliths, even in microservices, nano services. So basically, one is a coupled system, and another one is a decoupled system. Now, what is a coupled system? What is a decoupled system? What is a monolith system? What is a microservice system? All of this might be too much information for you guys at this point of time, but I just want you guys to at least be aware of these words as to what an architecture is, what is monolith, what is microservices, what is scale. Because if you know these terms, at least when you're free, when maybe one day when you're just done with all your work and you're chilling at your home, you just start understanding, okay, this guy had spoken about microservices back then, but I don't know what it is. Let me Google and check. Right. So I just want to put these words into your head so that it's very important for you guys. It just acts as a springboard for you guys to go through this. So the architecture evolution of software has always happened, as I told you, like from the last 50, 60 years. But the major evolution has been from monoliths to microservices. Monolith was a heavily coupled system. Say, for example, let's say the Coven example that we just took, right? So if Coven was written in a monolith architecture, if Coven was developed under the monolith architecture, what it essentially means is all the APIs, all the features, all the requirements, all the data management system would be all written in one single application. Now, when I say all the features, it includes user registration, OTP, PIN code search, vaccination registration, hospital, and basically every hospital has to enter, right, the number of doses they have. So entry side, so the data entry from the hospital side, the data entry from the government side, the data entry from the user side, again, the user registration, OTP, all the features, every small feature that you see on COVID should have been written in one single application. Now, what this the problem, what this causes is, first thing is the application becomes so huge that when you try to deploy this on a system, the deployment itself has a huge process that you have to go through. Second thing is you can't scale the system like however you want. See, always remember this. When you write, when you build a software product and when you deploy it, when you make it available for everyone across the world to use, there is always cost attached to it. You might deploy your product on a bare metal server, you might deploy it on a cloud server, you might deploy it wherever you want. There is cost attached to it all the time. You'll have to pay for the servers, you'll have to pay for the memory basically the databases you use. And if you use a technology which is not open source, you have to pay for it. So it's very important for software companies, for software teams to come up with a product which has high efficiency at very less cost. So let's say we developed Covin and we have everything that Covin requires is written in one single application. Everything goes to one single database. So we have one database and we have, say for example, Python. We have one Python application and then we have one React.js front end. So there's a React front end, there is a Python backend, and there is a MongoDB at the database level. I have deployed all of this. Now I have observed that I have a lot of traffic when it comes to registration of users. I'm not talking about registration for vaccines. I'm talking about registration of users. Now, so what I should technically do is I should ensure that my registration should happen seamlessly for n number of users. Right now, when the system was being developed, we developed it for 100 users per second. But now the request is 10,000 users per second.